Hello and welcome everybody. Good morning, good evening, good afternoon. Hi Will, how's it going?
I'm good. How are you doing? It's good to see
Good.
everyone.
Good to see you everybody. This is the final episode of the Full Stack GraphQL Book Club. So almost sad phase here a little bit. So we covered throughout 8 episodes all the chapters of the GraphQL Full Stack GraphQL Applications book, and this is the final episode. So yeah, it was a fun ride. It was interesting to hear about the progress, or to listen in and to see the progress of the app development goes from beginning first learnings to advanced techniques, authentication, and this final episode is now rounding us up, I guess, a little bit to more advanced techniques. The chapter title is called Advanced GraphQL Considerations. So we go a little bit more in, I would say, I guess, a little bit of an outlook, a little bit of what can be next steps kind of territory. Where can people go? And I think what does it say here? Relay style, cursor-based pagination, abstract types, relationship properties, all of that stuff is what we're covering. But if if you are interested in anything else, any question, particularly around GraphQL and Neo4j graph databases, then obviously this is is another chance of asking your questions. So we can see that we help you out with this. And again, this is this is the final chance indeed for winning a signed copy of the book. So Will has one more copy in his on his desk, and there it is, and he'll sign it. So before we go into exercises and all of that today, around in probably like 15-20 minutes or so, we will draw the winner. So if you want to win, you need to type in !Raffle in the chat on either Twitch or YouTube. It's unfortunately only working on Twitch or YouTube. So if you're watching this somewhere else, Twitter, LinkedIn, Facebook, you need to head over to either YouTube or Twitch. It's twitch.tv/neo4j or youtube.com/@neo4j. And then you'll see the live stream there, and then you can enter there. But don't worry, we will be announcing this at the final, I don't know, the final bell, I guess, before we close it in a few minutes. So you have some time. But now we dive into the episode. I'm looking forward to it. Yeah. Tether, nothing's final. What's with a sequel? I guess we'll talk about this maybe towards the end a little bit. What we're gonna do next, if we what the plans. We haven't decided quite yet. I think GraphQL is coming to a close a little bit, but Will and I, maybe we think about doing something else in the future.
Yeah, let us know what you'd like to see live streams on. It's
Yeah,
always fun to work on things that folks are interested in seeing. So definitely let us know.
absolutely. And it's !Raffle. You need the exclamation mark, otherwise the bot does not know that you want to participate.
I'm curious who has made it through and watched all 9 episodes of the book club now. Has anyone made it through all 9, or let us know how many you've joined live? I'm curious. I see some
Yeah,
some regulars in the chat here that I've noticed throughout. So it's been great to have a community of folks tuning in almost every week. We took a few breaks, I guess, over the holidays.
yeah, we didn't
spread out a
make it
little bit.
too easy for all of you. So we changed the dates, we changed the times. I mean, not in advance, but it wasn't always on the same slot. And we had obviously New Year's a break, so with all of that, it was a little bit of a wavy thing. But yeah, yeah, yeah.
Cool. Yeah. And also, I'm curious for those who have watched multiple episodes of this series, like which one was your favorite, and was it because of a certain topic that you thought was relevant or a cool demo? I'm also curious about that as well. Cool. Well, should we get into it?
Yep, let's.
Great. So the general format for these is to kind of review from whichever chapter we're covering. And so again, this is going to be chapter 9, Advanced GraphQL Considerations, which is the last chapter in the book. But the general format that we try to follow is go through the chapter pretty briefly, just try to tease out what are the main points that we cover in the chapter. Of course, answer any of your questions that come up. So as you have questions, drop those in the chat. We'll be sure to touch on those. But then also we want to make sure at the end that we work through the end of chapter exercises. And there's usually about 3 or 4, and we work through those and see what comes up. So that's what we're going to do today. So chapters 1 through 8 were focused on this idea of building full stack GraphQL applications. How do we build the back end using the Neo4j Graph database and the Neo4j GraphQL library, and the front end using React. We deploy that. We add things like authentication. We use Auth0. We use modern cloud services like Neo4j Aura, AWS Lambda to deploy our application. We did that in the last section, chapter 8, when we deployed everything to the cloud. And now in chapter 9, we are going to step away from the simple full stack app that we've been building and take a look at some core features of GraphQL itself that we didn't touch on in the context of the business reviews application we were building, but are still really valuable concepts to understand. And then we show how to use those concepts with the Neo4j GraphQL library. And the main points we're going to talk about here are the abstract types in GraphQL. So an abstract type is a type that can represent more than one concrete type. And so in GraphQL, there is a union and an interface. And we'll see when you would use one and the other, and how we use those with the Neo4j GraphQL library. Then we talk about pagination. So if I have a whole bunch of results, imagine I'm building a web application that, I don't know, I'm like searching for products or something, and I have a million products to show. Well, I can't just dump all those to the client and render those. I want to be able to paginate through some reasonable size. So we look at a couple different ways to do pagination, and we take a look at specifically cursor-based pagination using the relay connection model. So we'll talk about that. And then we see how to work with relationship properties. So in Neo4j, the property graph model that we use in Neo4j, we can store properties like attributes on nodes and relationships. And so far, we've only worked with node properties, but there can be some cases where we have some information that is relevant to both nodes on either end of a relationship. And in that case, we store the property on the relationship. So we'll see how to work with relationship properties using the Neo4j GraphQL library. And our abstract types, specifically the interface, is going to come into play there. Cool. So as you have questions, drop them in the chat. We'll be sure to touch on those. So jumping into abstract types here, the first one we're going to talk about is the interface. So we said that abstract types allow us to represent more than one concrete type. And the first one we're looking at is the interface. And so the interface allows us to define some required fields that the concrete type must implement. And the example we're using here is let's say I have information about both customers and employees in this API that I'm building. And I know that both customer and employee are people. So I declare this interface person, and I want to make sure that for any customer or employee that I'm modeling, that I have a first name, last name, and a username for our system. So those are the required fields to be a person. But then depending if you're a customer or an employee, you may have additional other fields that are specific to your type. So the example here is a customer has a shipping address and an employee has a hire date, so a date that they were hired. Then in our query type, so remember the query type is a special type, the fields of which become the entry points for our API. So here we have a field on query people. It gives us a list of persons, and the results can be customer object or an employee object. I'm just grabbing the person objects here. So that's interface when we want to define some specific fields that every type that implements the interface needs to implement. And this idea translates from lots of different programming languages like Java and so on that have this concept of an interface. Now, one thing that's really important is this idea of an inline fragment. So here we're querying our people query field, and we know that every people object, whether it's a customer or employee, is going to have first name, last name, or username. But only if it's a customer is it going to have a shipping address, and only if it's an employee is it going to have a hire date. So I can't just add in my selection set shipping address and hire date, because that field may not exist on one of my concrete types, right? So if I have an employee that comes back and they give me the shipping address, I don't know how to do that. GraphQL is going to throw us an error. So that's why we use inline fragments. So we have 3 dots here. We say on customer, give me shipping address. So what that means is the case where the object that's being resolved is a customer, well, then I'm going to include shipping address in the selection set. If it's employee, we're not going to include shipping address because employee doesn't have a shipping address. We're going to include hire date. So the inline fragment allows us basically to go through past that abstract type to the concrete type and say, okay, in the case where the object returned is of this type, here's the selection set that I want to be applied. And then, oh yeah, and we can also add the type name meta fields as 2 underscores and then type name, which is useful to be able to see what concrete type we're working with. So in the case that it's a customer, type name will be customer. In the case where the object is employee, type name will be employee. Cool, that's interfaces. The other abstract type that is available to us in GraphQL is the union. And union is similar to an interface. We use a union type to represent multiple concrete types. The difference between an interface and a union is that we do not define required fields that must be implemented for a union. So we don't necessarily need to have any overlapping or common fields that are implemented by the concrete types of a union. So here's this example, which spans 2 pages for some reason, but we're defining video. So video has a name and a SKU, like a product identifier. I don't know what What is SKU?
Keeping unit, I think.
There we go. Okay, stock keeping unit. I like that. Good to know. Some good trivia. How about ISBN?
When you work in my previous company, I was a hardware company, so selling actual real life products. So SKUs were always like, okay, important.
Gotcha. What about ISBN, Alex? Do you know what that stands for?
I think that's the international something for books, but I don't know international something book number, but I don't know what is exactly the S. I don't know.
Yeah, standard maybe.
Maybe yeah,
maybe
standard, yeah.
Something to do with books, right? So basically like the equivalent of a SKU, a product identifier, but for a book. And so there's some.
Yeah, I think it's international standard book number.
Okay, cool.
Yeah.
So some string representation that uniquely identifies a book. And so imagine here we are operating an e-commerce store. We're selling a bunch of different products. Well, I guess in this case, we're selling two products. We're selling videos or books. And so we don't want to duplicate all of the different ways to represent things that we're selling. So we want to wrap both the video type and the book type up into a single abstract type here that we've called product. So this is the syntax for declaring a union. We say union and then the name of the union type, which is going to be product, equals video and then a pipe, which is an or, video or book. So we're saying that a product can be a video or it can be a book. And you see unions a lot in search results where we may be searching for different types of things, right? So if we go to our e-commerce example, we're going to have some like product search page. I'm searching for, I don't know, content about GraphQL or whatever. The results are going to be videos or they're going to be books, but I have one abstract type, one common type to be able to represent both books and videos. And this is nice because in my UI, I may want to have different pieces of UI that are rendered in my list of results. For a video, maybe I can show like a little teaser trailer video. For a book, maybe it's just the image, something like this. But I want to have, again, one field on the query type to represent the search result for any of my products. And we use inline fragments, just like we saw with the interface type. We use inline fragments to work with the concrete types that come back from, in this case, a search query. And it's important to, again, to point out that unlike with interfaces, we haven't declared any fields that the concrete types of our union type will implement. So we can't really be guaranteed that we have, say, like a title or our employee example is first name. So in this case, everything except for the type name meta field is in the inline fragment for our selections. Cool. So that's just looking at abstract types in the abstract, I guess, not without any specific example. So let's take a look on how we use abstract types with the Neo4j GraphQL library. So we're throwing away the app that we've built up to now. So starting a new app, we install some dependencies. We either create a new database or delete everything we have in the database. And then we're going with this e-commerce site. So here's the data model we're going to start with. So we have a user. User can place an order, and then that order is going to contain videos or books. And so the type definitions to match that look like this, right? Where we have books and videos. A couple things to point out, I think we've touched on this before, but the ID directive. So again, directives, specifically schema directives, where we're adding these in the GraphQL schema, our GraphQL type definitions, as opposed to client directives, which are directives that we include in the GraphQL query. And we saw that one for working with local state. But anyway, schema directives in GraphQL, these are GraphQL's built-in extension mechanism that allow us to say, hey, there's some custom logic that should occur here. And with the Neo4j GraphQL library, we use directives to configure the generated API. But the ID directive, what this does is at creation time, we'll generate a random unique ID and store that as the value, in this case, for order ID. So I don't need to have the client at mutation time generate a random ID. We can have the server take care of that. And similar for timestamp. So for timestamp, this is going to save the current time of when this type, when this node, this order node is created, save the current server time to this date time created field. And we've talked about the relationship directives already. The relationship directive allows us to add some additional information that we store in the property graph model, specifically the type and direction of the relationship. Okay, but this isn't quite optimal because it's kind of awkward for us to look at an order and then we have to grab all the books in the order and grab all the videos in the order, and those are two separate fields, and then we're going to have like two arrays that we have to combine. What if we introduce a third category of product? Like that's not optimal. Instead, what we want is to introduce the idea of a union, so a product union that can be either video or book. Mm-hmm. And then on our order type, we're going to have just a single products field that is a list of products, but then those can be either videos or books. So now we're using just one field to represent that connection between the order and either video or book. But now it's just one field in our API, so that makes it a lot easier to query. But we're still representing this graph model with two different types. So the product type is an abstract type. It's not actually represented in the database. We don't have a product node. We just have book and video. Cool. So we've seen this sort of structure before, where to get our GraphQL API up and running, basically all we need to do is pass these type definitions to the Neo4j GraphQL library, and we spin up Apollo server, and we're good to go. So we'll see some examples. We go through creating some users in the database, then we create some products, which should be familiar. I think we introduced mutations in chapter 6, maybe?
Maybe.
Cool. So we're building up our catalog, so to speak here. But then we have users, we have products. Now it's time to create some orders. And so here we're creating an order for our user GraphLover123. And they are buying some books and buying a video. So note that when we are creating the orders and connecting them, we need to specify whether it's a book or video. So we can't just say this is a product, because we need to know what node label to match against. But then notice in the selection set, where we're returning information about the orders. For the products in the order, we're saying, give me the type name. So whether it's a book or a video, and then we use these inline fragments to define which fields to be returned in the case where it's a book or it's a video. And we can see here that products array that comes back, it's just one list that combines both videos and books. And in the case where we have a video, we see the type name. This is a video. That's going to match the node label that was created in the database. So video will be the node label. And we'll bring back the name and SKU. In the case where it's a book, we'll bring back title and ISBN. Cool. So we look at, we add some more orders here. Note that with the generated mutations with the Neo4j GraphQL library, we can pass a list, an array of input objects to create multiple orders in one operation, which is quite nice. Cool. Then we talk about pagination. There are two ways to do pagination: offset pagination, where we can pass in values for limit. So give me 10 results. Typically, we would sort those. So this does give me the 10 most recent. And then offset is what is going to allow us to paginate. So depending on how many results we want to render per page, when we want to grab the next page, we increment the offset number by the size of our page to give us the next 10 and the next 10 and so on. Our limit and offset numbers are pretty small here because we created some orders by hand. So there's only a few. So we paginate with just a few values in each page. So that's one way to do pagination. The other is cursor-based pagination. So rather than saying limit 2, offset 0, offset 2, offset 4, so on, we can use a cursor. So a cursor is just some opaque string that I get back that represents some place in my list of results that are coming back. And so I can say, give me the first 10 after this cursor. I get my page of results. And in that result, I'm going to have the cursor for the next page. So give me the next 10 after this cursor, and so on. So this is nice because we don't need to keep track of where we are in the offset, and we can just grab the cursor from our results and iterate to the next one. It's often the case also for using cursors to be able to avoid the case where we have some data that's been inserted and then I'm paginating with offset. I'm going to miss new stuff that's coming in. Typically, cursor-based approach can solve that. Now, to do cursor-based pagination with the Neo4j GraphQL library, we implement the relay connection model. So we introduce this idea of a connection type. And this, I think, can be kind of confusing, especially if you're new to GraphQL, and especially if you're sort of seeing this as part of GraphQL for the first time. But basically, you can think of the connection type as really representing the relationship between two nodes with some additional meta information. So for example, this page info field, this is going to have the value of our cursor, whether or not there's a previous page, a next page, and then the edges field is going to basically represent the actual relationship. So you can think of things like total count, page info as the metadata. Then the edges are going to be the collection of relationships, and the edges, of course, are going to have a node, which is the node that we are connected to, and then we have the fields on the node. So in this case, node is the order. And you can see here, we get back a value for a cursor. So then if we want to paginate to get the next page, we would say, give me the first two after the value of this cursor. So that is cursor-based pagination with the relay connection model. That connection model is also useful for representing relationship properties. So in the property graph model that we use in Neo4j, we can store properties on the node. So here our book has properties like title, ISBN, user has a username and a customer ID. Those are properties stored on the node, but we can also store properties on the relationship. And a good one in this context might be the quantity of either the videos or the books, the products that were placed in the order. So maybe I'm ordering 10 copies of one book, one copy of another book. That value is specific to both nodes. It's specific to the book and the order. I can't just store that on the order. I don't know 10 copies of what, 10 copies of this book. So because that value applies to both nodes, we store that as a relationship property. In the Neo4j GraphQL library, we can use interfaces to represent the relationship properties. So here we've updated our type definitions a little bit. We've introduced this contains interface that has a single field, quantity, it's an integer. And now on the products field, this is a connection between order and products. In the relationship directive, where previously we had the type and direction of the relationship, now we have a new argument, properties contains. So this is saying that the relationship between our order and either video or book, product is a union type here, is going to be this interface contains. So we can optionally store the number of products that are included in the order modeled as a relationship type on the contains relationship. And then that value will be available to us in the connection type for the order. So here's an example for now creating an order that has a quantity. So we say edge, quantity 10 in our create orders mutation. That means this order is going to contain 10 copies of full stack GraphQL book. I don't know why anyone would only order 10. You should get at least 20 for all your friends and family when you're buying that book.
This is the only place where you can get signed copies, though, and you don't even have to order them. You need to type in !Raffle to win this copy.
That's right, exactly. Cool. And so do we say how to retrieve those? Yeah. So then if we're looking at all of our orders, so orders are going to have a created date, an ID, but then in the products connection, so the connection between the order and the products, then I'm going to say, give me the edges. So give me those relationships between the order and the products. And now, in addition to just going to the node, which in this case is going to be the book or the video, now I can grab the relationship properties on that edge, on that relationship. It's called edges because this is what the relay connection model uses. We talk about relationships, but you can think of relationships and edges as the same thing. And in the response data, now I can see for this order ID, we have 10 copies of full stack GraphQL. Cool. So those are the main points that we touch on. There's a little, wrapping up section here where we talk about, okay, if you've gone through the book, where's a good place to go next? We talk about Graph Academy. I mentioned my website and blog where I publish some technical blogs as well. Those are good resources. Graph Academy is Neo4j's free online training site. There's lots of really cool hands-on workshops there covering application development, data science. I feel like I'm seeing a new course coming every week now. So
Adam is super active and he's adding new courses. So yeah, Graph Academy is definitely a great place to go.
Totally. Cool. So we've got some exercises to work through here, but I think it's time for our raffle.
It's time for the raffle. Yeah, let's final seconds now before I close it. Let's take one question from Tim while you all have the final chance to add yourself to the raffle. It's !raffle in the YouTube or Twitch channel chat, and then you're in. Tim asks, is a real-time chat application possible with Neo4j and GraphQL since WebSockets are not supported?
So for any sort of real-time application, if you're using GraphQL, I would take a look at subscriptions. So subscriptions are GraphQL's pub/sub mechanism. So you can subscribe to events. In the case of a chat application, you would subscribe to messages, and then the client then would receive an event, receive an alert via the GraphQL subscription that a new message has been added. So typically that is implemented through WebSockets. There's a few different ways that can happen, but that's the standard approach for web clients. So I would take a look at subscriptions. Subscriptions are now out of beta for the Neo4j GraphQL library, so they're now GA available as a feature. There's an example from, this was Graph Connect, not Nodes, looking at the subscription functionality in the Neo4j GraphQL library that Daryl and Andres presented. They built a collaborative pixel image editor demo based on the Reddit r/place, if you saw that, where anyone can sort of go on and draw the image of that using subscription. So I think that sort of real-time chat use case is great for subscriptions, or any sort of real-time collaborative editing is also a good use case for subscriptions. So yeah, I would start there when you're looking for support for that sort of real-time functionality. Yeah, good question.
Cool. Thank you, Tim. Thank you, Will, for the answer. And with that, I'm closing the raffle entries. So closed now. So thank you all for participating, and the bot will now choose a winner by clicking this. And Bob Simple is our winner. Congratulations, Bob. You win a signed copy of the GraphQL book. Exactly this very copy that Will is holding up into the camera. Will sign it for you. I need an email from you, so I will share in chat how you can reach me in a second, and we can continue with the exercises. So congratulations, Bob.
Great, fun. Congrats, Bob. You won the last raffle of our
very last
book club series.
Yeah.
Cool. So let's go through our final exercises here. So the first one says the price a customer pays for an item can vary. For example, the price may change or be temporarily reduced as part of a promotion. Add a relationship property to store the price for each item paid in an order. Okay, cool. So I thought for this session, since we've started a new project, and we're really focused on the GraphQL API aspect. We're not focused on deployment or adding things like connecting with Auth0 and these sorts of things. I thought instead of running our GraphQL API as a Node.js app, like we do in the book, I thought we would go through the exercises using the Neo4j GraphQL toolbox. So if you haven't seen this before, the Neo4j GraphQL toolbox is a web app. This is hosted online. Anyone can access toolbox. You just put in your database credentials to point it at whichever Neo4j database you're using. And then you get some really cool functionality without having to write any code. So one is the ability to define type definitions. So here, this is just a copy paste from where we left off in the book. If you worked through the book, we end up at this place from chapter 9. And I've just pointed it at a local Neo4j database. This is the data model that I have. And I just ran the mutations in the book to get to this database state. So you can see if I actually, here's the whole graph. So I have users. Where are my users? Users are purple. So I have user graph lover 123 and Bobby Tables.
It's a little bit small.
Oh yeah, I can zoom in a bit. Let's go full screen. There we go.
Yeah, that's better.
So I try to hack today with the problem of always having the text too small. So I'm not wearing my glasses, and so I figure I have to make everything bigger so I can see it. So yeah, so we have two users that have placed a few orders, and then orders can contain either books or videos. So just the data that we saw in the book chapter.
Mm-hmm.
So with GraphQL Toolbox, I put in my type definitions, and I can either create these manually, or I can hit this introspect button. And if I have data in my database, that will inspect the data and generate type definitions, GraphQL type definitions to match the data in the database. Then we hit build schema, and this will now generate that GraphQL API. But this is all running in the browser, so I don't need to manage like a Node.js app to develop this. And I have some nice interactive query. I can run my queries. I can visualize the results. So here's a simple one that's just grabbing the users. Cool. So we'll use GraphQL Toolbox. So we're going to update our type definitions here. And the question was, I already forgot the question. What does it say? Oh, the price the customer pays for an item can vary. Right. So if I have like a discount coupon or something like that, yeah, it's going to be specific to my order. Well, we already have a relationship property here, contains, which is on the contains relationship. So this is the relationship between the order and products. So we're using that to represent the quantity, so the number of that specific product that this specific order contains. So that's a good place to also represent the price paid for that product in this order, right? Not the price of the book for all orders, but for this specific order, since the prices fluctuate. So we'll add a, let's call it price paid field here to our contains interface. And then we need to click on build schema to update the schema for that. And now we need to put that to use. So here, for all the users, we'll just look at all of the orders. And specifically, so notice here that there's two ways to traverse from the users to the orders, either the orders field, which is just going to give me directly the order objects, the order nodes, or the orders connection. And the orders connection is going to give us those relay style connection types that have metadata about the connection, about the relationship. So like, that's where our relationship properties are going to be, as well as give us a way to get at the actual products in the order. Orders aggregate, this is going to allow us to do some aggregation operations. So we need to count the number of orders. If I need to do any sort of aggregation options, I can do that. But we're going to do the orders connection. And we're going to skip the page info. We're not interested in pagination right now. So we're going to go straight to the edges, to our relationships. And we can go to the node. Actually, I'm paginating in, or I'm going to the wrong connection field here, right? I mean, we can do this here. So we can go edges, node, but really what I wanted the connection for was the products. So I want the product connection. So I could have just said orders, which would have skipped the edges and node here and just gone to the order node, but that's okay. So we're going to go from the products connection. We're going to skip the metadata and just go to the relationship properties here that we want. So we have quantity, and we also now have price paid. And then we want to know, like, okay, what quantity of what, price paid for what. So we'll go to the node. This is going from the relationship. This is the contains relationship. So order contains product. And we'll grab the type name. And so we can run this now. And we can see here that we already have price paid. So I did update my database ahead of time with both quantity and price paid for each order, just so we had some values to work with. But I don't know what book this is. I don't know what video this is. And if I go here to my node and I'm hitting Control Space for autocomplete, tell me what fields can I select on the product type, and all it tells me is type name. And that's because product is a union, so we need to use an inline fragment to say ... on book. So now in the case where the product is a book, I can do Control Space, and now we know that, okay, I have title and ISBN available. And then similarly, let's capture those videos. Video has title and SKU. Cool, so now we've added price paid, so we can keep track of the price paid specific to an order and a product. So we can represent things like discounts or whatever. Some users get a better deal than others for whatever reason. Cool, so that was our first exercise. Number 2 says, write a cipher directive field to compute the order subtotal. Be sure to take into account the quantity of each item included in the order. Cool, yeah, so now we have, for every product and every order, we have the price paid, and we have the quantity, the number. So we multiply those, add that up for each order. That's gonna be the subtotal of the order. So we're gonna do this using a cipher directive. Cipher directive allows us to add custom logic to our schema using Cipher, which is a super powerful feature. So I'm going to say extend type order. We'll call this subtotal. It's going to give us a floating point value. We'll add the cipher directive, and the cipher directive takes a single argument statement, which is going to be a cipher statement that has whatever logic we're adding here. So this is going to be something like match this. So this is a special variable that's added for the cipher directive fields to represent the currently resolved node, which in this case is going to be the order that we're currently resolving. So from this order, we want to look at the contains relationship to what? To our product node. This is an error, but we're gonna talk about why this doesn't work in a second. Let's go ahead and write the rest of it. And what are we going to turn? Well, we need to sum up the quantity. So we're going to say r dot quantity. Is that how you spell quantity? I'm having a senior moment here. Quantity.
It's good to me.
Quantity. Yeah, right. Okay, so quantity times what did we just added this one, price paid. So for all of the products, we added relationship properties to represent the number of that product and the price paid for the product. So we're going to return that. That's going to be our subtotal. But I said this is not going to work. While I go run this and see if this works, let us know in the chat, what value is this going to give us if we run this, and why is it not going to be correct? So anyone can answer that before we verify that it doesn't actually work. That'd be fun. So we're going to hit build schema. That's going to update our schema to now include that subtotal. And let's just go to all orders and let's just get the subtotal for each of those. Did anyone say in the chat what are we going to get here?
We got a no idea from Olala. So I think it was a little bit, maybe it was too quick. I don't know if you want to show it again, or do you want to directly run it?
Let's run it and then we'll fix it and talk about why. So do we get zeros for all of our subtotals? So we did something wrong. If we go back here, we said match this order contains a product and then sum up the quantity times the price paid. Well, the reason we get 0 is because there's no product nodes. There's no node with the label product in the database. These union types are not they're not added as node labels to the database. So we need to say this is a video and this is how in Cypher we can represent multiple labels to match on is with this this pipe. So this now says go from the order, follow the contains relationship to videos or books.
I see.
So let's run that again. Cool, and now we get actual values for the subtotal because now we've done that traversal properly. And we could add here the products and say when it's a video, give us the title and SKU, and when it's a book, give us the title and ISBN, and so on.
Oh yeah, here we see.
Cool, that's a good one. So the third one here, write a GraphQL query to paginate the items included in an order. First using offset pagination, then using cursor-based pagination. Can we go from last page to the first page as well as paginate from the beginning? Mm-hmm. Cool. So let's just start with, let's just grab the first order here. So we're not paginating through every product in every order. So we'll say limit 1. So this is going to give me just one order, and then we want to see what the products are in that order. And we'll do our inline fragment. So when it's a video, give me title and SKU. And when it's a book, give me title and ISBN. And I can run this and we get three products. So not enough products to really necessitate pagination, but imagine we had 1,000 products in here. We didn't want to display them all at once. We want to be able to page through those.
Yep.
Well, so first we want to do offset pagination. And we're going to say options, limit. Let's do a page size of 1 here since we only have 3 things. So we're going to say limit 1. So just give me one thing and offset 0. Just give me the first one. We get 1. And then to get to the next page, we increment offset by the size of our page. So offset 1 gives us the next one. Offset 2 gives us the next one. If we do offset 3, what are we going to get? Nothing, because there's only 3.
Yep.
Cool. So that is the offset way to do that. The other way to do this is cursor-based pagination. So let's do this for the same order. So we've got one order here. And let's add some fields here. Let's add order ID and subtotal. So we have some info there. Oh, what did we do? Let's start over. Orders, options, limit 1, grab order ID. Okay, so there's the order ID for our order. And we want to paginate through the products using cursor-based pagination, which we said earlier. We use the relay connection model to do that. So we want to go to our products connection, and we're paginating with a page size of 1. So it's first 1. The reason this isn't limit 1 to match the format here is that this is specified by the relay connection model that this should be first. So that's why we use first. Mm-hmm. And we want to add our metadata information. So does this have another page? Does it have a previous page? And then the start cursor and the end cursor. Actually, let's see what this looks like if we just take out the first here. Cool. So we'll run this, and we can also let's also bring back the edges. So the quantity, the price paid, and then now the actual. So those are our relationship properties for the product. And then let's bring back the actual products, again, using our inline fragments. In the case where it's a video, title, SKU. In the case where it's a book, title and ISBN. Okay, so let's run this. So we're not doing any pagination here other than saying, give me just one order. We want to paginate the products. So we go to the products connection. So this is the relay connection type. And the first thing we do is we grab the metadata. So is there another page? Is there a previous page? Well, no, because we're returning all of the product connections. And then in edges, we see, yep, here's our 3 products. So to do our pagination, we're going to take the value of the cursor here. Well, first what we're going to do is we're going to say, give me the first one here. And now we can say, yes, there is another page. There is not a previous page. We're at the first page. We take the value of the cursor, and we're going to say, give me the first one after this cursor value. Run that again, and we get now, we do not have a next page because we've returned them all, but we do have a previous page. So we can paginate again using the value of these cursors with the relay connection type.
But the orders did not change now, or was I, or shouldn't they have changed?
So yeah, that the products here,
or the products rather, yeah.
Yeah, so I think that's a good point. I think because we're using a union type here to represent the products, I think that something gets a little scattered in this case. In the book example, we use cursor pagination. We're paginating on orders, which are a concrete type.
Mm-hmm.
And so in that case, we can see that we're getting back the proper number of order nodes here. Here we're getting the same, all of the products because it's a union type. I think something's scattered there. So that's something to look into.
Okay.
Yeah. Cool. Let's look at paginating with the relay connection model. Again, we got little fuzzy on the results here, but we did see how the cursor values were changing and the metadata telling us whether or not we had another page to work through or the previous page, depending on where we were in our pagination. Cool. So we got through our exercises. We got through chapter 9, and we got through the book. Congratulations. Yay. All around.
Congratulations indeed to everybody. Everybody that participated, everybody that followed along, everybody that took part with questions and all. Yeah, I mean, if you're watching this after the fact that we are streaming this live, and you have some questions, I guess community forum, Discord is the best way to go. Then you can, or Twitter, but probably the community forums or Discord are better ways to ask your questions, and we have a lookout for any open questions on these pages, so you can see if anything goes to your what you have. And with with that, I think we're at the end. So really, it was really fun. It was really interesting. So I hope you all enjoyed it and had a good time. This video is the end of the book club, but all the episodes are available. Will and I, we might do something in the future, or with another topic maybe. If anything is particularly interesting to you, then obviously let us know. So it would be really cool to see what topics are interesting to you most, and where do you think, okay, a stream series might be interesting. We will have a think about as well. And
Absolutely.
yeah, absolutely.
And if you haven't downloaded the book yet, anyone can download PDF version of that for free, thanks to Neo4j, who's sponsoring the book. So be sure to, the link for that is in the description of the video if you're watching that, or
Yeah,
I think
can
Alex
use
put
the
it in the
bot
chat as well.
one last time for it. Exclamation mark GraphQL. Well, it doesn't work on Facebook, so well, whatever. But it works on YouTube and Twitch. So this is the link to the book, so where you can connect, download the PDF version. Yeah, if you didn't win a signed copy, so unfortunately, not everybody can win.
Congrats to everyone who won. That's fun.
Yeah, exactly. Yeah, you got some shout out to your voice, Will. Olala says William has a great voice. I'd like to hear him narrating something. So maybe you want to do an audio edition of the GraphQL book.
Well, you're in luck
Yeah.
because here first announced live breaking news coming out. We're bringing back the GraphStuff.fm podcast.
Oh, that's very cool. Yes.
We haven't done an episode of graph stuff in, it's been over a year now, I think. So Jason and I and the rest of the developer relations folks decided it was time to bring that back. So Jason and I recorded an episode yesterday. I'm putting the final editing on the episode. So if you like listening to me yammer on about graph stuff, check out graphstuff.fm and probably later today, maybe tomorrow at the latest, we'll have a new episode out for you.
That's cool. Yeah, that's yeah, very cool. Yeah, I think with that we are at the end. So yeah, if you want to reach either myself or Will, you can use the Twitter or the community forums or anywhere else. Links are in the video description, so it would be nice to see you. And yeah, I think with that we are at the end. And yeah, I hope to see you at another live stream somewhere, somehow. I'll be back tomorrow, actually, at this time on another book. One episode only, though, not a series. But our colleague Ravi's wrote a book on graph data processing with Cypher. That's happening tomorrow in the afternoon. There is second point on the list. So it's happening here. So if you are interested in that, join me then. Otherwise, check out neo4j.com/events for everything else we're doing. Give the video a like and subscribe to our channel either on YouTube or Twitch. And yeah, it was fun. I had a good time. Hope you too. And yeah, see you soon.
Bye, folks. Cheers.
Thank you very much. Bye-bye.